this lecture, I will explain what is speed regulation. The speed regulation of a DC, the speed regulation of a DC motor can be defined as it is the ratio of change in no load speed to full load speed and it is expressed as percentageal fraction of full load speed. So this is percentage speed regulation. N no load minus N full load divided by N full load into 100. As we discussed in the previous lectures, the regulation and efficiency are decides the machine's performance. If it is a generator, we should concentrate on voltage regulation. If it is a motor, we should concentrate on speed regulation. So these are the problems, some of the problems, most important problems and most repetitive problems in coming in university examinations. A 230 volts DC shunt motor. First draw the diagram of DC shunt motor. So this is the armature and the field winding is connected in parallel with the armature, and this is about line current. The current flowing through armature is IA and the current flowing through field winding is ISH. 230 volts means our supply voltage is 230 volts. Takes an armature current is IA is equal to 3.33 amperes at rated voltage, that means 230 volts, and at no load speed of no load speed is 1000 rpm. The resistance of the armature circuit and field circuit are 0.3 ohms and 160 ohms. RA is equal to 0.3 ohms and RSH is equal to 160 ohms. Calculate at full load the speed and the developed torque in the case of, so this is N1, this is IA1 and RA and RSH is also same, right? N2 is equal to how much? In the case of armature reaction, weakens the no load flux by 4%. So 4% means phi2 is equal to 0.96 times of phi1. Suppose if phi1 is 100%, it is weakens by 4%. So it is weakened by 4% means the new value of flux. What is the new value of flux? The new value of flux is equal to 0.96. Okay, so that is 0.96 times of phi1, that is 96% of the phi1. So first calculate the EB naught. This is under no load condition, that's why it is called as IA naught. V minus IA naught into RA. What is the supply voltage we are getting is 230 and IA naught is 3.33 and the armature resistance is 0.3. So if you calculate in your calci, then you got it as 229.09 volts. What is the shunt current? V divided by RSH, that is 230 divided by 160. 230 divided by 160. So in your calci, if you solve it 230 divided by 160, then I got it as 1.4375 amperes. the armature current IA1 is equal to IL1 minus ISH. IL1 minus ISH. So here the line current calculate at full load, right? Speed and the developed torque in case of armature reaction weakens the no load flux by 5%. Here one term is missing in this problem. The line current, yes, line current is at full load. The line current at full load and rated voltage is there, that is 40 amperes. So in the question you can add that one. So IL1 is 40 amperes and ISH1 is 1.4375. So that should be equal to 38.5625 amperes. Then calculate the EB1 at full load, V minus IA1 into RA. The voltage is same, that is 230 minus IA1 is 38.5625. The armature resistance is also constant, 0.3. Then you got it as 218.4312 volts. We know that N is directly proportional to EB by 5. And from this, N0 by N1 is equal to EB naught divided by EB1 into phi 1 divided by phi naught. The no load speed is 1000 divided by N1 is equal to EB naught is 229.01 and EB1 is 218.4312 and phi 1 by phi 2. As I said, the phi naught value is 100%. The phi 1 is 96%. That should be equal to 0.96 of that of phi naught. So the ratio is 0.96. From this the speed is equal to 993.5483 rpm. So after that, TA naught, this is under no load conditions, how much the torque is produced. EB naught IA naught divided by 2 pi N naught by 60, 229.01 into 3.3 divided by 2 pi into 1000 divided by 60, 7.2167 Newton meter. Then the torque is directly proportional to flux into IA. TA naught by T1 is equal to phi naught by phi 1 into IA naught divided by IA1. T1 is equal to 7.2167 into 0.96 into 38.5625 divided by 3.3, then you will get the 80.9584 Newton meter. So this is the final answer. So once again I am explaining this problem. A 230 volts DC shunt motor takes an armature current 3.33 at rated voltage at no load speed of 1000 rpm. The resistance of the armature circuit and field circuit are 0.3 ohms and 160 ohms. Calculate at full load the speed and the developed torque in case the armature reaction weakens the no load flux by 4%. The line current at full load is 40 amperes. So first of all, what is the relationship between the voltage and speed? So directly it doesn't have. EB is directly proportional to N and EB is equal to V minus IRA for DC shunt motor. You can calculate the back EMF under no load conditions, V minus IA naught RA. So for that IA naught is given, that is the 3.3 amperes the armature is taking into RA is 0.3. Then I calculate the EB naught under no load condition. After that you can find the IA1. Why? Because the line current is given at full load is 40 amperes. Then find the back EMF at full load. This is at full load and this is at no load. If you calculate under no load condition and full load condition, and we have a relationship of speed is directly proportional to EB by phi. N2 by N1 is equal to EB2 by EB1 into phi 1 divided by phi 2. So here that N1 or N0 is called the no load speed that he has given as 1000 rpm, and EB0 is also you can substitute, and the ratio of phi 1 by phi 0 is 0.96. Why? Because the flux is weakened because of armature reaction. When the current flows through armature conductors, the effect of armature flux on main field flux is called armature reaction. Armature reaction. Due to this armature reaction, the net flux will be decreases. So that by 4% means 0.96. Substitute in this equation, then you will get the full load speed. So the previously the speed is 1000 rpm, and you will check it. So most of the students they commit a mistake here by substituting the formula in the to the values in the formula. So if you are getting n1 is greater than 1000 rpm, your answer is wrong. Why? Because as load increases, as a mechanical load increases, definitely the speed will be decreases. Check that the no load speed is 1000 rpm and the full load speed is less than that of the 1000 rpm. And then find out the no load torque EB0 IA0 by 2 pi N0 by 60. Then I got it this answer. We know the relationship torque is directly proportional to flux into IA, where TA0 by T1 is equal to phi 0 by phi 1 into IA0 by I1. So from this I can calculate T1 is equal to TA0 into phi 1 by phi 0 into IA1 divided by IA0. So TA0 is 7.2167 and phi 1 by phi 0 is 0.96 and IA1 is 38.5625 and IA0 I am getting is 3.3. And finally this torque is called the full load torque. What is this torque? This torque is called the full load torque. So coming to the next problem on DC series motor. So first of all you should draw the diagram of DC series motor. The series field winding is connected in series with the armature. The series field winding is connected in series with the armature. So I am giving this supply voltage. The 200 volts DC motor means 200 volts is supply voltage. Runs at 1000 rpm when operating its full load current of 30 amperes. Then N1 at full load is 1000 rpm. The motor resistance is 0.5 ohms. So RA plus RSC is equal to 0.5 ohms. And line current IL is equal to IA is equal to ISC. That should be equal to 30 amperes. The magnetic circuit can be, yes, the flux will be unaltered. The flux will be unaltered. So the first question is the load torque is increased by 44%. Suppose the previously the torque is at 100%. Now the torque is increased by 44% means 100 plus 44%. That should be equal to 144%. 144%. So that should be equal to 1.44 times of full load torque. 1.44 times of full load torque. Okay, so let us say this 100% is full load and this you can assume at T1, then T1 is equal to 1.44 times of full load torque. So then torque is directly proportional to flux into IA. For a DC series motor, flux is directly proportional to IA. So finally torque is directly proportional to IA square. Torque is directly proportional to IA square. T full load divided by T1 is equal to IA1 divided by IA2. So IA full load divided by IA2 whole square or IA1 whole square. So because the full load is assigned here. What is the full load torque now? The full load torque by T1, that should be 1 divided by 1.44. See here, T1 is equal to 1.44 times of T full load. But if your T full load is equal to 1 by 1.44 in 1 by 1.44 into T1. So what is the IA at full load is 30 amperes divided by IA1 whole square. Then from this equation, IA1 I got it as 36 amperes. So this is called the 36 amperes. So calculate the back EMF at full load. V minus IA full load into RA plus RSC. So 200 minus 30 into 0.5, that should be equal to 185 volts. And EB1, V minus I1 into RA plus RSC, 200 minus 36 into 0.5, that should be equal to 182 volts. 182 volts. Then N is directly proportional to EB by 5. That is EB divided by IA. N full load divided by N1 is equal to EB full load by EB1 into I1 divided by I full load. Why? Because I is goes upside, right? So then this is IA1. Full load speed is 1000. Now I want to calculate the N1. So EB full load is 185 and EB1 is 182 into 36 is the IA1. 30 is IA full load. Then from this I got it as 819.82 RPM. If the load torque is increased, that means IA is also increased. Okay, so IA increases means the speed will be decreases. See here, the full load speed is 1000 RPM. The full load speed is 1000 RPM. If a load increases, what will happen? In the problem, he is clearly mentioned that as load increases, the load torque is increased to 44%, means definitely the load current is increases, the speed is decreases. Check that your answer is less than 1000 or not. Yes. The second question is the motor current is 20 amperes. Okay, so EB2 is equal to V minus IA2. This is called the IA2 into RA plus RSC. The supply voltage is 200 minus 20 into 0.5. That should be equal to 190 volts. Then again, N is directly proportional to EB by IA for series motor. Why? Because the flux is directly proportional to IA. For DC series motor, N full load divided by N2 is equal to EB full load divided by EB2 into IA2 divided by IA full load. So 1000 divided by N2, that should be equal to 185 by 190. So 20 by 30. So that is N2 is equal to 1540.54 RPM. See, IL is 20 amperes. Generally, full load current is 30 amperes. Then the load current is decreases. Yes or no? The current drawn from the supply is also decreases because both are same. Then obviously speed will be higher. Check that the speed you are getting is more than 1000 or not. And the next problem, a shunt motor is operating at 230 volts, takes an armature current of 6 amperes at no load. So again, V is equal to 230 volts and IA naught is equal to 6 amperes and N naught is equal to 1200 RPM. and Ra is equal to 0.25 ohms. Find the speed and electromagnetic torque. Yes, speed is equal to how much, and electromagnetic torque is also how much. When the armature current takes 36 amperes, yes, Ia1 is equal to 36 amperes. With the same flux, yes, flux is equal to same. That means phi 2 is equal to phi 1. So for this problem, what is the solution for this one? We have a formula n is directly proportional to Eb by 5. So Eb naught you can calculate V minus Ia naught into Ra naught. Sorry, Ra. V is 230 and Ia naught is 6 amperes. The armature resistance is 0.25, that is 228.5 volts. If Eb1 is equal to V minus Ia1 into Ra, it is 230 minus 36 into 0.25, that is 221 volts. This is a no load back EMF. What is a no load back EMF means? This back EMF is developed under no load conditions. This back EMF is developed under, so this 36 amperes. Then substitute the value. N0 by N1 is equal to Eb0 by Eb1 into phi 1 divided by phi 0. These are same. And N0 is 1200 RPM divided by N1 is equal to 228.5 divided by 221. So from this I got it as 1160.6127 RPM, revolutions per minute. The no load speed is 1200, but if the load increases, yes, load increases, that means for 36 amperes, definitely the speed will be reduces. Check that the speed is less than 1200 or not. Yes, it is less than 1200. On no load, the torque is T naught, right? T naught is equal to Eb naught Ia naught divided by 2 pi nt n60. Why? Because the power is equal to omega t. T is equal to power by omega. Eb naught Ia naught divided by 2 pi n naught by 60. Eb naught is 228.5 into Ia naught is 6 divided by 2 pi into 1200 by 60. That should be equal to 10.91 Newton meter. And the torque is directly proportional to Ia. Why? Because torque is directly proportional to flux into Ia. This flux is constant. That is mentioned in the problem. So T naught by T1 is equal to Ia naught divided by Ia1. Then T1 is equal to 10.91 into 36 by 6. That should be equal to 65.4604 Newton meter. This is the new answer, new value of torque. So these are the most repeated problems on speed regulation of DC motor. So thank you guys.